Hey everybody, welcome back to Workshop Quick Takes. Today we are going to be looking at a couple things that have failed around the house, and I was curious, so I was like, hey, I wonder what happened to those things. What? Oh, come on. Yes. So anyway, we're going to be taking a look at 3 things that have failed around the house recently, starting with this Apple iAdapter. Or actually one exactly like it. This one here is still a good one, but we just have one that went to bits. And so we're going to take it apart and see if we can figure out why. Second thing, this LED light bulb. Or again, one exactly like it. It came in a 2-pack. This one here is just about gone, I think, based on the fact that this one was in the rear porch and the other one was in the front porch. And what? Okay, the one in the front porch, it went out, or nearly went out actually. It was just glowing dimly. This one here is still glowing, but it's been running just as hot as the other one, so I'm pretty sure it's about done too. And then third and finally, a ground fault outlet, of all things, behind the refrigerator. One just like this. Just quit working one day and suddenly our fridge isn't running. Well, I guess somebody caught it. So be that as it may, we're going to go dig into those 3 things and just see if we can figure out, hey, what's in there, and is there any clue as to why it isn't doing what it should do? Come along for the ride. Alright, this one should be a little bit fun to deal with. This is an old 2.5 amp iPad charger brick for, any sort of iOS device. As far as I know, this is an authentic Apple one. We can look here on the back side, and it does say designed by Apple in California. I've seen some obviously fake Chinese ones that'll put that on there. As far as I know, this one actually is in fact real. So we'll take a look inside this thing and see why it's not outputting power anymore. This, of course, is one of those universal ones. This part comes off and is presumably just fine. Didn't have any issues with it until one day it just wasn't charging anymore, so... But, hey, as long as we're all here, why not just put a meter on it and do a quick continuity check? Worst it can do is not beep. Okay, meter's working. Good there. Good there. Prongs here look fine, not seeing any looseness or whatever. They seem to be okay. So it should have been getting power to the unit. I'm expecting to find something bad inside, although it's anyone's question of whether it'll be visible or not. Honestly, I never popped one of these open before, so this should be a new adventure. I'm not trying to save it, so... There we go. Wow. Impressive. Fairly certain that the difficulty I'm having getting into it here means this is an authentic Apple part. A lot of times the third-party cheap Chinese ones will look right, but they just pop right open because the plastic's not put together very well. There we go. Okay. First thing I'm looking for, because I know it's not done sometimes in the cheap aftermarket ones, is whether this metal part here is connected to the circuit ground. And it is. So that's a good sign. Even though there's no ground connection here, that thing should not just be floating. Second thing that gives me a good feeling about this being authentic, which I'm pretty sure it is the fact that there's a good separation groove here between the high voltage and the low voltage sections. Yeah, there we go. So there's the groove. There's the power connections coming in. And there's this connection going to the circuit ground. That's what you want to see in an authentic one. You can already see I bashed in the capacitor there while I was popping it open, but that's damage, tool damage I just caused. That's not the proximate cause of failure. As is that I just caused. Looks like I popped the cap off of, what was that, a little capacitor? Little input fuse there, I think. Let's just get the old meter out again and see if that fuse has continuity still. So one of them is connected to here. Yep, fuse wasn't blown. Well, as long as we've gone this far, let's go ahead, pop those wires off since we're not going to be using this ever again. I previously, before ever popping it apart, I should note that I looked at the USB port just to make sure there wasn't like a bad pin depressed or something in there, but they all seem to be sticking up, so that wasn't the issue. I do see a little transistor here. I can't guarantee that it's working, but I don't see any venting or smoking on it. A couple little surge suppressors in there. Well, this is an interesting one. I don't think I'm going to get much out of it. I don't see any visible damage other than that which I caused by opening it in the first place, but I do know it was definitely not working. In any case, it was a fairly old unit. It had been used off and on quite a lot, left plugged in near a chair that was in common use where an iPad or a phone was often sitting, so these things do go bad after a while. I don't know for sure why this one did, but it is what it is. Have to replace it. Okay, next up let's take a look at this light bulb here. It looks like a conventional Class A light bulb with GE's like blue tinted reveal coating. It is in fact an LED light bulb, and it was in the front porch for a couple years and I noticed it didn't seem quite bright enough. Now if I turn it on here under the camera, it looks fairly bright. I'm not sure if I can turn the exposure down enough to... There we go. Now you can see that there's a lot of light here at the bottom, not so much at the top. So it's clearly going bad, and the amount of lumens it's putting out is probably closer to a conventional 25 watt bulb. See what that says there. It's supposed to be putting out 1140 lumens. It's nowhere near that now. So we're going to break it open today and see what's going on. Now I want to try, if I can, preserve this so that I can plug it back in after it's broken open and just get an idea of what's really happening. So what I'm going to do is I've got this old sock that's got a hole in the end, so it was due to be used as a paint rag anyway. Let's just try breaking that open inside the safety of the sock and see what's going on.
Hammer time!
That went off with a nice little bang, didn't it? Ooh, smell the argon too, or whatever was in there. Let that clear for just a second. Okay. Very gently reach in there. Well, there we go. You can already see that the LEDs on here look really dark, so not sure which ones are actually gone, but we're going to find out. And just because I have cut myself before on some of these videos, I'm going to be smart and use gloves this time. I mean, this is broken glass. Let's see if I made any short circuits. I don't think so. Still looks pretty clean. So I'm going to unplug that, screw it back in there, turn it back on, and see what's happening. Oh, look at that. I can already see a problem. One of the LEDs just fell clean off. Where'd that little guy go? Oh yeah, look at that. Yeah, there's the bottom side. There's the top. Maybe that was part of the problem. Maybe they just delaminated from that lead-free solder after a while. Who knows? In any case, still gonna put the gloves back on. Where was that one anyway? Oh, right there. So yeah, maybe that disrupted one of the pads and just plain took it out. Only one way to find out. And this time, so that I'm not grabbing this fixture at all, I'm gonna go ahead and turn it on first and then plug it in. And just to be clear, I am plugging it into a ground fault outlet over here, so, you know, if it actually does try to zap something, it should go pretty quick. Nothing. Add that backwards. Oh, still nothing. That one fell off, and that was the end of that. But in any case, we can definitely see what some of the problems were. This little guy, and it is unplugged, so let's go ahead and just bring that up closer to the camera and take a look. So yeah, those LEDs, I mean, they all look pretty dark, like they were running hot. And I don't know if some of them actually burned out and interrupted some of the pathways, or if, you know, some of them were just getting loose and that was going to be the end of them anyway, but there it is. That doesn't work anymore, so we're pretty much done with it. See if there's any sort of ballast or whatever down in the bottom of this thing, or if it's... Oh yeah, look at that. The glue's pretty loose. Oh yeah, there's a ballast down in here. Yeah, a little insulating piece right there. Interesting. But yeah, it's buried down in there, so it should dig out with just a little bit of effort here. Let's try Mr. Long-Handled Screwdriver. Again, I'm not trying to preserve this for posterity. I just want to see what kind of circuit's down in here. Wow. They really packed a lot down in there. Huh. Would you look at that? There's actually a complete switching circuit with a little transformer. I mean, it is a GE lamp, not some just generic Chinese whatever, so put a proper switch mode circuit in there. And they crammed an amazing amount of stuff in such a tiny space too, so that's some pretty good engineering. It's disappointing that it failed, although not entirely surprising, because these LEDs on these little aluminum backing sheet inside the bulb, they don't really have a lot of heat sinking capability, and at some point it just went bad. But overall, nice design. Well, if anyone's curious, I did look at one of these LEDs here, scraped off some of the yellow, and I could count 3 dies inside. So if we look at this here, we've got 8, 8, 8, and 8 is 32, and 4 on the end is 36. So you can calculate the voltage from that. If you have 36 times 3 is about 108 volts of dropping potential. So yeah, somewhere around 110 volts or so is probably where that was being driven. Again, they were actually using a switch mode converter. Here's a close-up picture of it. So yeah, nice setup, just finally got old and died. I have here a failed ground fault outlet, or we call them GFCIs here in the United States, ground fault circuit interrupter. Here's the box from the replacement one. You can see it says GFCI right there. But that one there was a 15 amp. This one here was originally a 20. And I'm disappointed. It was only in for about 10 years. I changed it out after moving into the house. But yeah, I chose the 20 amp model, even though the circuit, you know, it's a 20 amp circuit, so I can do that, but it didn't actually require 20 amp on the outlet. But I thought, hey, it'll be heavier duty, and it's even supposed to be their pro grade. This was Leviton, yeah, spec grade is what they call it. So I got no idea why it went, but okay, it's dead, it won't reset, no power comes out of it. Let's just pop it apart and see if we can physically see any damage in there. And we got 4 screws to remove, it looks like. Okay, there we are, and apart it comes. Not a whole lot to see so far. I mean, we've got our trip and reset buttons there. That one's test. This one here. That bottom one's reset. It's currently in the locked position, but it was not resetting. Here's the main body of it. Looks like we have a little surge suppressor here that's part of the control circuit. And, you know, I don't see any venting or anything on that that would indicate a possible failure mechanism. I mean, it all looks pretty clean. There's not any arcing or signs of distress in the main body of the device here. So I guess the next step is to try and get this part out. Well, there's one of the contacts. And then the other one here. There we go. So there's the 2 pieces that actually take the receptacle prongs, both made of brass. So if nothing else, I can throw these in the recycle bin, and the recycler will be glad to see a little extra brass showing up in their stream. Okay, this piece, the ground bar comes out next. This one does have a couple little brass tabs to receive the ground prong from a standard US power cord. The rest of this appears to just be steel. What else have we got? Not sure how the rest of that comes apart. Okay, here we go. I think it's just snapped together, so I'm going to have to... there we are. Yeah. So that side's ready to come out. What about down here? Maybe if I get rid of that sticker? No, that's a... Let's try a little screwdriver to use as kind of a pry bar here and see if that lifts this assembly out. I mean, this thing's defective and bad, so I'm not too worried about damaging it any further. There we go. Okay. A couple of the screw terminals that feed the sides. So there's the actual breaker mechanism anyway. That's interesting in its own right. we have, let's see here. These are the contacts that actually close in the circuit. So when one of these is installed down here, when these are installed, those close in or out in order to make or break the circuit. There's the coil, the solenoid coil that actually pulls it open. Test and reset. Nice little piece of kit. I mean, it's amazing how compact they managed to make all this to fit it in there. Fun thing about these, and I really don't have the time to try and disassemble a circuit on one of these. I mean, I probably could, but it's not my usual thing except when I'm doing repairs. These things work on the principle of a current differential. And the nice thing is the current differential will work even if for some reason you have a missing or faulted ground. Basically, current differential means that when you have a source to a load, you shouldn't have any power bypassing it. The current in should equal the current out. If it doesn't, you have a problem. And so these can be very sensitive down to just a few milliamp and trip at a speed that is fast enough in most cases to prevent a human from suffering a fatal electrical shock. Yeah, so there we are. Okay, there's a controller chip right there. Number of surface mount resistors and capacitors. Well, I'm not seeing anything obvious. I mean, the contacts are clean. The coil, I don't know if there's a problem with the coil at all or not, because I can see some like little dust marks or flaking or something that just looks a little odd, like it was overheated or something, but those might just be left over from manufacturing. Now there is some black mark or something down below it, but I think that's just a, Okay, there's a small transistor right there, so that's one possible failure point. Maybe that transistor went bad. And then there's this little IC controller here. Looks like down under this little white encapsulation there's a couple little coils there too. I'm not sure if those are sense coils of some kind. Oh, sure enough. Okay. Looks like we have a connection here and a connection here feeding into these, and a little coil loop around here that's probably detecting current. Well, X289 it says. There's a little transistor out of circuit. That's not a part number I recognize. I'll have to do a little research here and see whether I'm looking at a transistor or a MOSFET. Okay, I'm still not 100% sure what's going on here. This transistor has a number on it that I cannot read. I've tried searching for it on Google and I'm just not coming to any conclusions. But there are two things I know that might help me figure out what it is. If it's a bipolar junction transistor, or conventional BJT as they're called, and it's working, then one of these is going to be the base, one of these three terminals. And when I figure out which one that is, I should see somewhere between about 0.55 and 0.75 volts, forward volts, when I do a diode check. So if I do a diode check and just kind of cycle through these, what do I find? Okay, nothing on that one. Nothing on that one. Okay, with positive on the middle terminal and negative on this outside terminal, I'm getting 0.725. That looks like one valid diode junction. So now, if that's the case, I get nothing there, I get a normal one there. That's a pretty good clue that I might have a transistor with a blown junction. Another way I can check is to turn this over to an ohm check. If this were a MOSFET, then I would expect to be seeing either, some sort of resistance between some of these. And I get nothing, even on these two where I was previously able to measure a forward voltage. So that's a pretty good clue I'm dealing with diode junctions. Let's assume that is a transistor and that it's failed. Let's also assume that the most likely purpose for that transistor in this circuit was to drive the coil. Now, again, I'm looking at this coil and I'm still feeling a little bit odd about the color variation I'm seeing on there. It's discolored like it's been overheating or something, and I can see some black down there underneath that I'm just not sure about. But here's one thing I can check. Let's just start at a 200 ohm test, and then let's just take a test across this coil. Nothing. Again, still seems like it might be open circuit. So I guess the next thing to do is to try and disconnect this coil here and just pop it out of there and see what that black stuff is underneath it. There's the bottom side of that same coil, and I am seeing some blackening on it. That really makes me suspicious, because then I see the same black stuff on here that's not supposed to be there. So my best guess is that this coil got some shorted turns and started overheating, and eventually it started actually melting the enamel off the wires and created this black pooling down here, which I'm pretty sure is not some sort of resin or attachment or whatever. And so then finally the current that was required to drive that coil got high enough that it blew out that transistor, and that was the end of the circuit. I guess that is what it is. I mean, it was in use for 10 years, so eventually all things break. And there we have it. Our first one, the Apple iAdapter. Couldn't figure out why it wasn't working. All we knew is that it definitely wasn't. Who knows? Things eventually get old. The LED light bulb. What? Okay. The LED light bulb, meanwhile, it was still working just barely until we popped it open, and that was the end of that. And make up your mind. That was the end of that. And so then third and finally, the ground fault outlet. Well, that one was pretty cool because we could see a coil that had physically failed in there, and that's why it wouldn't reset. It had just plain burned out and taken out some other parts with it. So that's the price of living with modern technology. Things do get old and die. So hope you enjoyed seeing this little exploration with us. Tune in next time, whenever that is. Has anyone seen my phone?